Hey Ryan, I can absolutely help you with this one, sir. Let me grab a sketch of her. So what we're going to do here, we're going to use the quotient rule. And we use the quotient rule in situations like this where we can't take the square root of these numbers, right? The square root of 120 is a decimal that goes forever. The square root of 5 is a decimal that goes forever. So what we're going to do is we're going to apply the quotient rule, which is literally this. I'm just going to rewrite this as the square root of 120 x to the 4 over 5x. So the square root of all that. And I know that's probably like a super subtle thing, but that's what the quotient rule states. It states that if we have a numerator and a denominator that are both square roots or cubed roots or whatever, we can just think of it as a fraction and then take the square root of the whole thing later. So what that enables us to do, now let's kind of do some division here. 120 divided by 5, no idea. So I'm going to just do her out old school. 5 goes into 12 twice. Subtract, I get a 2. 5 into 20 goes 4 times. So this becomes the square root of 24. And now we'll deal with our x's. Remember, when we have two exponents with the same base, and we're dividing them, we subtract the exponent. So this is assumed to be exponent 1. So 4 minus 1 gives us x cubed. Okay? So that's kind of our first step right there. We just subtract, and that's that. Now what can we do here? We got to reduce this a little bit. So let me make some room. I'll erase my scratches. And here's kind of getting at your question, I would say. So remember, when we're going to reduce this radical, I want to factor out the biggest perfect square I can get out of 24. All right? So remember, perfect squares are 1, 4, 9, 16, on and on. Okay? So that's what I'm thinking about here. So 24 is going to break down as the square root of 4 times 6, right? Where 4 is the biggest perfect square that I can factor out of 24, right? We can't do 12. 12 is not a perfect square. 16 doesn't work. Now what we're going to do with our x's, I'm going to pull out the biggest perfect square that I can with my x's, and that's going to be x squared. So again, I'm going to rewrite this x cubed as x squared times x. And this is kind of the reverse of the product rule. Remember that when we multiply two exponents with the same base, we add the exponents. I'm just doing the opposite of that, so I'm factoring it out. And basically with square roots, an even exponent is our biggest perfect square. So I'll geek out about that in a sec, but let's take this one down just to say. So I can evaluate the square root of this. The square root of 4 is 2. The square root of x squared is x. You can do an absolute value on x if you want to be real fancy and just prove that it's always kind of a positive number. Then the square root, and we have 6x left in there. So this is going to be our final answer. So when we evaluate a perfect square, it just becomes a number. It's no longer underneath the radical or the square root symbol. Okay? And here with the x's, whenever we take the square root of x squared, technically it should be the absolute value just to indicate that it's a positive. You don't have to do that, but I'm just saying. Okay? Now, I want to geek out. That's your answer, buddy. I hope that helps. If it doesn't, let me know. But I just want to geek out about a little more exponents with you, because here's a bit of a shortcut, which is pretty neat. And I'll work it out. I'll work it out a couple ways. Let's say we had to do the square root of x to the 5. Okay? Well, if I was going to break this down, there's two ways to do it. Way one, I'm going to factor out my perfect squares, which is x squared times x, right? And again, just the reverse of the product rule. 2 plus 2 plus 1 gives me 5. Then again, I can evaluate my perfect squares. So I'm going to have x times the square root of x. And the one under the square root is just this guy over here. That's still an irrational number. And then I can combine this, so I get x squared times the root of x. So x, the square root of x to the 5th would simplify to this right here. But another way to think about it, and a bit of a shortcut really, is that any even exponent is a perfect square when we're talking about variables. Okay, so I could just see this another way. I could see this as the square root of x to the 4 times x to the 1. I'll write the 1 in. Okay, where 4, because it's an even exponent, that's going to be my perfect square. And the effect of taking a square root of any even exponent is it basically just cuts it in half. So half of 4 is going to be x squared, and we have this root x left over. So that's kind of a neat trick. A square root of any even exponent, cut it in half. But in general, factor out the biggest even exponent, or perfect square, you can, and then take it from there. Hope that helps you, buddy. Let me know if it doesn't.